So right now it's recording, right?
Yes.
It is?
Yeah. Yeah, okay. It shows up on ours and it says this meeting is being recorded.
Okay, great. But I wonder where the file goes when I'm finished recording, though. Okay. Maybe this has the answer. Recording option, sure. It's recording with a PowerPoint, though. You receive an email when the recording is complete. Okay, great. All right, that's good to know. All right. Put that right there. Okay. Let me reply to this person, and then I'll, if they want to join the Zoom meeting too. Okay, so when this meeting's over, I'll put this on my YouTube channel so that other students can see. So next, we're going to ask their age and then how many tickets they're buying. So please enter your age. And then see out. Please enter how many tickets you're buying. So you can do it up to here, right?
Yeah.
Okay.
I think the only thing that I ever have troubled with, and that I've ever had trouble with, is like, because I know how to do the math problems.
Mm-hmm.
What it is like actually implementing it into C++, because I know that it has to go like backwards, kind of, right? Like the
What
answer.
do you mean by backwards?
Like the answer equals blank plus blank or blank times blank type of thing. That
answer equals blank times blank. I'm not quite sure what you mean by that.
So like, I know that you have to do the different integers. Mm-hmm. So if like the regular tickets cost $15, mm-hmm. and let's say you're buying 3 regular tickets.
Yeah.
So it would be, I know one of them would be the answer, like 15 times 3 equals this.
Yeah. And then you apply the sales tax.
Mm-hmm. And that's the part I get confused on.
Oh, that's okay. We'll work this out. So if I pull this out and put it over here, so we see that the way I see it, we're going to have a multi-way if statement for calculating the total cost. And it's going to have 5 different branches, 1 for each of these.
Okay.
Does that make sense? So I'm actually going to do this. So if age is greater than, I'm going to do it top down because I think it's easier that way. So I'm going to start with greater than or equal to 75. So yeah, sorry, you're too old to ride. And then next, if they're 60 or older, mm-hmm. they're a senior, and then the ticket price will be $12. Okay? And then I'll go E, then D, then C, then B, then A. Okay? So
Right, because you go
age,
with the highest to the lowest.
yeah. So if age is greater than 75, I will do something, okay? Else, if age is greater than, what did I say was next? 60?
60 to 74.
Yeah. Yeah, so 60, I will do something else, right?
Mhm.
So far, so good?
Yes.
Else? Oh, I see we have more people joining us. Hello.
Hello, Professor.
How are you doing today?
Yeah, I'm doing great.
Good.
Yeah.
Yeah, you just joined us while we're in the middle of this.
Yes, Professor.
So you can figure out the rest of this structure, right? If age is greater than, what's the next number?
18.
18, right?
Mhm.
Age is greater than 18. And then else. And then
Age.
age 6.
Yeah.
Else if age is greater than 6. And then else. We don't have to put an else if here because this is the catch-all. If you're less than 6, then this is the only alternative. We covered the other 4 possibilities, right? So there's an else if.
Yeah.
If you're not, if you have 5 options and you can't choose 4 of them, then there's only one option left. So this is your catch, right? So in fact, I'm going to put a comment here. I'm going to say less than. So are we good so far? Is everything making sense?
Mhm.
Okay. So now I think we're going to have to make a new variable called total cost. I'm going to put it here, okay?
Okay.
And now we know how to calculate the cost. We're going to take, depending on which group they're in, the cost is going to be, it's going to be the number of tickets times whatever cost is going to be different in these 3, okay? And then we're going to add a 3.5 sales tax. Does that make sense? Okay, so if this individual is older than 75, they can't ride because they're too old to ride, right?
Yeah.
So what I'd like you to do is say something like, I don't know, see out. Sorry, you are too old to brownie face or something, you know? The same goes if they're younger than 6, right?
Yes.
So it would be a good idea to put this same line over here, except we're gonna say too young. Okay, so the real math happens when we're here or here or here, okay? So if I can calculate the price for 1, you could probably figure out how to find the prices for the other 2 as well, right?
Yeah.
Okay, so if they're, so I'm going to start over here when they're 60 or older. So when they're 60, they're a senior. Their price is $12, okay? So I'm going to say total cost, because we declared this variable over, oh, I didn't make it yet. I'm going to say double. Like that, okay? Now the reason why I have total cost as a double is because this is a monetary value. It's going to be dollars and cents. So it's not going to be an int, right? It has to be a floating point number, right?
Yeah.
That makes sense? So total cost is going to be equal to 12 times the number of tickets they entered. So tickets. That's not so bad, right?
No, but wouldn't the 12 be considered a floating number or a magic number?
What do you mean?
Well, just because it's not, shouldn't we be like saying like, oh, if like the senior cost or equals 12, and then you can do senior cost times 12 times the amount of tickets or something.
Are you saying doing something like this? Like int senior cost equals 12, like that?
Mhm.
And then
Yeah.
we say senior cost times tickets?
Yeah.
You could do that. It accomplishes the same thing.
Okay. So it doesn't matter really if I put like the 12 in the actual like else if statement. It's just or if I like declare it as an integer beforehand. Like
No,
how
it doesn't matter. I could just have 12 in here, you know, and I could just not have this variable at all. It makes no difference. The math is exactly the same, right?
Yeah.
And now, so here's one thing I also would like you to know. So the fact that total cost is a double is the fact that even though 12 is an int and tickets is of type int, it's going to give us a double. Well, actually, I hope it does. I believe it should, actually.
It'll give a double after you implement the sales tax.
Yeah, that's true. So, you know how we're going to implement the sales tax?
Mm-hmm.
So if we want to add a 3.5 sales tax, and that's the same as multiplying the total cost by 1.035. Do we understand why that works? Like, oops, I didn't mean to do that. Like, I'm gonna say times 1.035. Do you understand why this is adding the 3.5% sales tax?
Not really, no.
If we multiply a number by 1, that's the same as not changing it at all, right? But if we multiply it by 1.035, we're adding that's the same as adding 3.5%. Do we understand the math?
Yeah. Now I get it. I got it.
Because this is the same, like I could say plus this thing here times 0.035. But this and this makes these like terms. So can't I just put them together and just say 1.035? I can do that, right?
Yeah.
Yeah.
It's the same thing.
So let's go ahead and now I know I didn't write these yet, but I'm going to check this case to see if it works, okay? So age. Let's check the younger than 6 thing first, okay? So if I enter 3, it should say that we're too young to ride, right? Take as a I'll say doesn't matter that much. Yeah, it says sorry, you're too young to ride. Now if I ran this again and I tried greater than 75, so I'm gonna say 76, okay? I'm gonna put sorry, you're too old to ride. Do we understand how this if statement's working? So because age was greater than 75, this statement here turned out to be true, so it'll execute this line of code and ignore everything else. Because that's what we like discussed in the lecture video today, if you've already seen it. Right?
No, not yet. But I do remember this stuff.
Okay. So the way it works is it checks them one at a time, and it'll keep going until it finds something that's true. So like for instance, if it sees that this is true, like say I entered an age of 61, this evaluates to be true, okay? So we would do this. Now, even though 61 would be greater than 18 and 61 is greater than 6, even though these would both be true, it doesn't even check these because this evaluated to be true first. It wouldn't even bother looking at these. Does that make sense?
Yeah.
Okay. Okay, so we have the total cost for age 60. You can evaluate, I think you can use this to figure out the costs for the other ones as well, right? So I'm gonna let you tell me what to type. Okay?
Okay.
So what should I type here?
It's going to be total cost equals I think it's going to be 10 for a children's ticket, or a regular ticket is 15. So 15 times the amount of tickets they buy. And then outside, it's going to be times 1.035.
Now you understand why I put parentheses here first, right? Because I did mention in the lecture video.
It solves the parentheses first.
Yeah, it solves the parentheses first. And then it'll do this, right? So what about over here? It's almost exactly the same, right?
It's the same thing. The total cost equals, and then it's going to be 10 times tickets times 1.035. Put 55.
Okay, so it looks like we covered requirement number 3, right? And 4. So, oh, we did 5 too, because I counted in the 3.5 sales tax. So all that's left is part 6. The program finishes with addressing them their name and telling them how many tickets they bought. So I'm actually going to put that in here. 3 different cases because I'm going to say see out. So what should I say to the user? Thank you, your name, and then the cost of your number of tickets is this much, right?
Yeah, so see out, thank you, and then it's gonna have that space with a space, and then you're gonna have the little thingies with name. Yeah, the chevrons with the name. And then
let's put an exclamation point. So it'll say that.
And then it's gonna say you're buying.
You're buying.
And then it the chevrons with the tickets.
Tickets. Tickets. Mm-hmm. Or right.
Well, and then it's gonna be the total cost, right?
Total cost. Well, let's put some end lines. So I think it looks nicer with spaces. So now the reason why I decided to have this in the if statement is because if I had it outside of the if statement, it would execute regardless of these choices, right? Because this is waiting out here. Well, maybe it's better if I show you. Like, if I had this over here instead of in there,
Mm-hmm.
it would actually throw an error because if I did age is, if I said age is 76 and I did this,
When
I
it's
don't have a function here that evaluates the total cost. So when I see out total cost and there's no value in it, it's gonna throw an error. Does that make sense? That's why I have them in the if statements. If that makes sense. So we're actually going to repeat this exact same line for here and here, right? With no difference, right?
Yeah.
Okay. So let's try running this to see if it works, okay? So name Bob. So what age do we want to try first? Which age group?
Let's do um, the middle one, the adult tickets.
Okay, so when they're older than 18, so I'll put 19, okay? How many tickets they're buying? Let's just say one. Okay. Thank you, Bob. You're buying one ticket for 15.825. I believe that's correct, right? Calculator. 15 times 1 point. Oh, my bad. Let me. 15 times. Oh, let me do this again. Sorry. 15 times 1.035.
Oh, you typed in 1.055 for the
Oh, my
sales.
bad. Yeah, that explains it. Oops. Let me fix that. 3. Try it again. Bob, 19. Yeah, that looks correct, right? 15 times 1.035. Yeah. So, so I put a couple things to make this a little better because I actually do the labs that I make and try to see how I can like improve it. So I put this section called tips here. If you want to enter a full name, you get line instead. But we already did that, right? But if you want to specify dollars and cents by setting precision to 2 decimal points, then you would include IO manip and you would write this line. Maybe it's better if I show you, right? So, well, I think the first thing we can do to improve this is put a dollar sign up front. So over here, where's dollars? like that, right? Now, when I was calculating this before, did you notice that it's spitting out 3 decimal points here? We can set it to 2 decimal points if you wanted to. And that's what I was saying earlier in the tips. So what we can do is we can go over here and say include IOManip. That stands for input-output manipulation, okay? And then we can copy this line, see this? See out fixed show point set precision 2. We can put that here before anything else. This makes it so that any number that we output will show 2 decimal points. And yeah, so we can run it again if we want. So Bob 19, we're buying 1 ticket. Now it says we're saying we owe $15.52. That's better, right? Because it
Yeah.
shows 2 decimal points. Okay. So that's actually the entire lab. That wasn't so hard, right?
No.
So what exactly did we need help with here? So you needed help making this if structure, right?
Yeah.
So for anyone else in the Zoom meeting, does anyone else like need help, or is there any confusion that needs to be cleared up? Now I'm talking to all of you right now. Oh. What was the third include? Oh. The third include was IOManip, because I said over here, if you wish to specify dollars and cents by setting precision to 2 decimal points, then include IOManip and then include this line. Okay. Does that answer your question, Daniel? Okay, cool. So now, before you get the idea to like turn this in right now, it would probably be a good idea to test the other cases too. So we already know that the greater than 75 works and the less than 6 works, right? We checked to make sure that the greater than 18 works. Let's try greater than 60 and see if that works. So let's put in name, any name, age. We want to test greater than 60. I'll say 61. How many tickets we're buying? Let's just say 1. So it looks like we're buying 1 ticket for $12.42. That's 12 times 1 times 1.035. So it looks like it works. Let's test the younger than 6 now, or the greater than 6 now. So I'll say Bob, age 7, 1. Yeah, it looks like it works. So okay, so now like do we realize now that these labs, they're not hard, right? They're pretty easy, right? Now I hope they are, because the way that I structured the midterm is that you have questions that's kind of similar to this. And then you have to code it yourself, right? So if I gave you a similar question that's just like this, do you think you can do it on the midterm or
Yeah.
the final?
So I just kind of want to go a little bit further. What if, like, say you wanted to buy multiple tickets at different age prices? So, like, you bought one
Oh,
ticket
well,
at
this program
60.
doesn't account for that. I wanted to make this as simple as possible. So just one age group, this
Okay.
many tickets. So yeah, I didn't want to make it too complicated because this is just beginner level programming, you know. So yeah, so this looks like that's kind of it. So is there any other questions or from anyone? I'm gonna post this recording on my YouTube channel like a little later so that other people can see. But if you have any questions, like I really did try to make these instructions make as much be as clear as possible, you know. But but if anyone needs assistance, that's what I'm here for, you know. But aside from that, I think we're just about finished here. So you all know how to submit this, right?
Yes.
Okay. So I said you submit it the same way you've been doing the activities, where you just send me an email with this, and you just say lab 1. Give me one screenshot with the following test case: your name, your age. You don't have to put your real age; just put any integer, and then the number of tickets you're buying. So I need the screenshot, and I need one CPP file, and it'll be the easiest 5% of your grade of your life. Okay.
Alrighty.
So did everyone already see the code? Well, I'm gonna put this on YouTube, but so if we don't have any more questions, I think we're just about finished here. What do you guys say?
I say yeah.
Okay.
Thank you.
So so uh so would you guys be down to oh, someone said something. So would you guys be down to do this again for lab 2? Because I think in my syllabus, let me just try to find the syllabus. So my syllabus, lab 2. Okay, so lab 2, it's all about user-defined functions and arrays and vectors. So maybe we can have another lab meeting. Well, actually, I have a version of my tentative schedule with colors. Let me try to. Yeah, so we have. So we need to finish. So lab 2 pertains to user-defined functions and arrays and vectors. We can have another meeting when we're like right after we do the lecture. So September 18th, or we can do it September 25th. Like it doesn't matter so much. Like what day is good with you guys? Well, I'll send an email asking, but do you want to meet again for lab 2 on either the 18th or the 25th? Or you guys want to think about it and you'll get back to me later? because lab 2 is easy too. Okay, well, I guess we're finished here. So unless anyone else has any more questions, I'll, so everyone saw the code already? Okay, I guess we're finished here. So I'll stop sharing. Okay.
Thank you, Professor. Bye.
Bye. Yeah. So I'll see you guys later. Thanks for coming.